Right now, somewhere in South Korea, artificial intelligence is building an entire construction project without a single human on site. In Switzerland, a man just flew alongside commercial jets at 500 kilometers per hour wearing nothing but a jetpack strapped to his back. Off the coast of Busan, engineers are finalizing plans for the world's first city that floats on the ocean and can relocate itself to avoid hurricanes. And hovering above Shanghai, specialized drones are preparing to physically move an 8,270-ton historic building across the city like it's a chess piece. These aren't concepts from science fiction movies or futuristic predictions for 2050. These technologies exist right now, operating in the real world, performing tasks that should be impossible according to everything we understood about physics, engineering, and human capability just a decade ago. What makes these inventions genuinely terrifying isn't just that they work, it's how completely they're rewriting the rules of what technology can accomplish. Engineers worldwide are simultaneously amazed and unsettled because these breakthroughs aren't incremental improvements, they're quantum leaps that skip entire generations of expected development. When you see what's at number one, you'll understand why experts are calling this the most disruptive technological period in human history. Let's explore 8 inventions that crossed the line from impossible to inevitable so quickly that most people don't even know they exist yet. In South Korea, construction sites are transforming into something that looks more like a science fiction movie than traditional building projects. The country has developed what might be the most revolutionary construction system in history, a completely autonomous ecosystem capable of building massive infrastructure projects without direct human intervention. This isn't remotely controlled equipment or assisted machinery. This is full autonomy operating at a scale that seems impossible. The system consists of 3 integrated components working in perfect synchronization. First, specialized drones create 3-dimensional maps of terrain with millimeter precision, analyzing every characteristic of the construction site from soil composition to elevation changes. These aren't simple aerial photographs. They're detailed topographical analyses that provide more data than traditional surveying teams could gather in weeks. Second, a complete fleet of autonomous vehicles moves using drone data to excavate, crush, and transport materials without human drivers. Heavy machinery that typically requires skilled operators now functions independently, making decisions about optimal paths, load distribution, and coordination with other vehicles. But the third component is what elevates this from impressive to genuinely revolutionary. A central hub located outside the construction site where a superintelligent AI analyzes work performed and optimizes operations in real time. This artificial intelligence coordinates massive machines simultaneously, executes construction with precision that eliminates human error, and continuously adjusts operations based on conditions. Experts have confirmed this system builds complete projects faster and more accurately than any human team could achieve. The industrial implications are staggering: dramatically reduced construction times, complete elimination of workplace accidents, and precision that no traditional construction company has managed before. We're watching the birth of an industry where humans become supervisors rather than laborers, where AI makes split-second decisions about projects worth billions. Meanwhile, aerospace engineers have been developing something that sounds completely insane: a hotel that flies permanently through the skies without ever landing. The Sky Cruise project isn't a concept drawing or distant proposal, it's a detailed engineering plan for the largest aerial structure ever conceptualized. This flying hotel uses compact nuclear reactors and 20 propulsion engines strategically distributed to keep 5,000 guests suspended in the air 24 hours a day, 7 days a week. Its nuclear power system enables continuous flight for months without refueling, creating what's essentially a permanently airborne city. But here's where it gets truly revolutionary. Sky Cruise features an aerial docking system where mobile platforms extend from the hotel to connect with commercial airplanes mid-flight, allowing passengers to board and disembark while the hotel continues its eternal journey. This completely eliminates the need for traditional airports or landing procedures. Inside, the facility houses pools with panoramic views thousands of feet above Earth, floating shopping centers, rotating restaurants offering views that change constantly, IMAX cinemas, and even a miniature golf course. Everything operates through autonomous artificial intelligence controlling everything from navigation to guest services. The psychological implications are fascinating. Guests would experience perpetual motion, never touching ground, living in a space that's simultaneously a vehicle and a destination. It's the ultimate expression of human ambition to conquer the sky, not just by flying through it, but by living permanently within it. In Switzerland, engineers accomplished something that belonged firmly in superhero movies until recently. They created a flying suit that allows humans to soar at 500 kilometers per hour alongside real airplanes. The Alpha Jetman suit isn't a prototype or experimental technology. It's a functional device that's been tested extensively over real terrain. This jetpack generates enough power for extreme flights covering kilometers of distance without needing landing strips, airports, or ground support. The suit contains 4 jet engines, but what's genuinely remarkable is the integrated flight intelligence. The system automatically maintains optimal altitudes, compensates for turbulence and wind changes, and continuously monitors pilot safety. When it detects dangerous conditions, the entire system reacts instantly to keep flight stable. It operates during prolonged flights, functions in various weather conditions, and performs acrobatics that would be impossible without computer-assisted stabilization. The implications extend far beyond recreational aviation. Rescue workers could reach completely inaccessible places, mountain peaks, offshore disasters, collapsed buildings, in minutes rather than hours. Explorers would have access to territories that are currently impossible to reach. It's literally mechanical wings transforming humans into steel birds with capabilities that defy our biological limitations. The barrier between human and aircraft is dissolving, creating a new category of personal mobility that didn't exist before. China has been revolutionizing construction in a completely different way by making it invisible. Chinese engineering companies developed inflatable construction domes designed to solve one of the oldest problems in building: noise and pollution at work sites. These giant air structures completely enclose construction sites, eliminating noise to the outside and preventing dust or polluting particles from escaping. Unlike traditional methods that try to minimize these problems, the domes simply eliminate them by creating controlled ecosystems where construction happens inside what's essentially a temporary building. The potential applications are immense. If successfully implemented globally, this technology could end construction nuisances in dense urban areas, allow work during extreme weather conditions, and create safer work environments where air quality is controlled and monitored. Workers inside these domes operate in climate-controlled conditions regardless of outside temperatures. Rain, snow, extreme heat, none of it affects operations. The domes demonstrate how China is revolutionizing even the most basic construction aspects, transforming work sites into futuristic capsules where building happens in isolated environments. In Shanghai, structural engineers achieved something that seems to violate fundamental laws of physics. They developed technology to move entire buildings weighing 8,270 tons as if they were toys. This system uses advanced robotic hydraulic jacks functioning like legs of a giant robot, allowing relocation of entire structures with precision surpassing any traditional demolition method. The Shikumen complex, a historic structure in Shanghai, was successfully moved using this technology with extraordinary results. The system isn't limited to small structures. It can relocate entire buildings autonomously with engineering supervision, opening possibilities for reconfiguring cities. Historic structures that would traditionally be demolished to make way for development can now be physically moved to new locations, preserving cultural heritage while enabling urban progress. The implications are profound. Cities are no longer permanent arrangements of immovable structures, but flexible configurations that can be optimized over time. Valuable buildings in poor locations can move to better sites. Infrastructure can route around historic structures instead of destroying them. We're witnessing the birth of dynamic urbanism, where city layouts evolve physically rather than just on planning maps. In Japanese laboratories, engineers created something that sounds like science fiction: exoskeletons that eliminate human fatigue entirely. These aren't bulky mechanical suits requiring training and maintenance. These are sleek body enhancers that minimize stress on joints and waist through advanced impact absorption. The running exoskeleton allows movement on any terrain without feeling tiredness or muscle pain. The system executes completely autonomous physical improvements. It detects body movements, plans muscular optimizations, and enhances capabilities without user intervention. The same company developed versions allowing users to lift 22.5 pounds to heights of 6.6 feet without effort, Support systems for delivery workers, mail carriers, and warehouse personnel activate automatically, augmenting strength precisely when needed. The true revolution is that physically demanding jobs no longer destroy human bodies. Natural capabilities get enhanced, and traditional physical limitations become obsolete. We're looking at technology-assisted human evolution, where our biological constraints no longer determine what we can achieve physically. The line between human and machine isn't just blurring, it's becoming functionally irrelevant for tasks that previously required exceptional strength or endurance. Japanese specialists also created what might be the most immediately useful invention on this list: the world's first full-size drone equipped with 2 robotic arms. This technological giant weighs 44 pounds but can carry 22 additional pounds while reaching speeds of 37 miles per hour. Its 30-minute autonomy might not sound impressive, but it's sufficient for saving lives in situations where traditional rescue is impossible. Consider this scenario: someone is drowning at sea, and weather conditions prevent boats or helicopters from approaching safely. This drone flies up to 3.1 miles in altitude, resists adverse weather, and delivers a lifesaver directly to the victim in minutes. Applications extend far beyond maritime rescue. The drone works at altitudes dangerous for humans, handles toxic or explosive loads, and performs construction tasks in completely inaccessible locations. Its interchangeable capabilities make it versatile for situations previously requiring humans to risk their lives. We're witnessing the birth of truly useful emergency robots, machines that don't just observe or report, but actively intervene in life-threatening situations with capabilities humans simply don't possess. But nothing on this list compares to what South Korea accomplished off the coast of Busan, the world's first sustainable floating city. Oceanics Busan isn't a concept or proposal, it's an actual city being built that floats on the ocean and adapts to climate change while growing and relocating as needed. This revolutionary aquatic metropolis features interconnected platforms supporting residential, commercial, and recreational spaces powered entirely by renewable energy. The most remarkable aspect is that it can expand and relocate in real time, making traditional urban concepts obsolete. Urban planning experts have admitted something profound. This city completely redefines global urban development in the face of rising sea levels. Traditional cities have fixed foundations that are fundamentally vulnerable to climate change. Oceanics Busan has oceanic adaptability. It can house entire populations and strategically position itself to avoid natural disasters like hurricanes, tsunamis, or storm surges. An investment of millions offers solutions that coastal cities worth billions cannot match because those cities are anchored to ground that might be underwater within decades. UN habitat developers have acknowledged that floating cities might not be experimental alternatives but necessary futures for coastal populations worldwide. We're looking at humanity's answer to one of the greatest challenges of the 21st century. How do we live on a planet where sea levels are rising and coastal areas, where most humans currently live, are becoming increasingly uninhabitable? The answer, apparently, is we learn to live on the ocean itself, building cities that move with the water rather than fighting against it. These 8 technologies represent something more significant than individual breakthroughs. They're evidence that we've crossed a threshold where the impossible becomes reality faster than we can psychologically adjust. Construction without workers, hotels that never land, humans flying like birds, buildings that walk, bodies that never tire, drones that rescue, cities that float. Each invention independently would be remarkable. Together, they suggest we're living through the most disruptive technological period in human history, a time when the gap between science fiction and engineering reality has effectively disappeared. The future isn't coming. It's already here, operating in the real world, waiting for the rest of us to catch up.